So to start off, let's talk about what is fragmentation. Fragmentation in an index is the same as fragmentation you have in a computer or a laptop or a hard drive. This fragmentation occurs most oftenly by DML actions taken on a table that has an index on it. Now, when you create an index on a table, you create the B tree, and the B tree is going to be a permanent structure. And once you have created it, it's going to maintain and describe and hold that structure for that data. However, data in a table doesn't always remain the same. Data gets moved, it gets shifted, it gets deleted, updated, and changed all the time. And when you make these changes, you end up creating empty spaces in the B tree, and these are known as memory bubbles. This is pretty much the same concept you have with working with a hard drive in a computer. Over time, when you're moving files, deleting, adding, removing, and doing all these different operations, your hard drive becomes fragmented. And this is simply that you have moved data around, and now the information is no longer stored in an optimal manner. It's kind of scattered, and on the disk where it's being stored, there are blank pockets or empty sectors where there should be data but it's been moved somewhere. So DML actions on a table with an index cause fragmentation. And DML operations are the main cause of it, but there can also be issues when it comes to something like page splitting, which can also cause fragmentation. And page splitting is simply put is when you have data and you're inserting it into the different nodes in it, we know that a node for a leaf page or a node for any of the balance tree components is only 8 kilobytes. Now, when adding data together, there's no guarantee that you're going to have exactly 8 kilobytes per row. Sometimes you might fill up a page, get to 7 KB, and then the next row you have to insert is going to be 3 KB. Well, we see that it won't fit in the same leaf page. So what will happen is 1 KB will be stored in the leaf page to take up the rest of its space, and then the remaining 2 KB will be stored in the next leaf page. This is page splitting. So when this happens, then let's say you perform a deletion or you move that row or do some kind of other operation, you now are going to have a bubble in 2 pages versus 1. So page splitting is another issue that can cause fragmentation. And overall, fragmentation is the main cost that comes with using any type of index. When you put an index on a table, you create that balance tree, which is, as a permanent structure is storing all that data. And in a database, data is being shifted, changed, and altered on a frequent basis. So having indexes actually in a database is something that is debated, whether or not it's optimal or better for the settings. It all comes down to the cost. Whenever you have an index, fragmentation occurs. Then it really depends on the table. If I'm in a database and I have an employee table, and I know an employee table only has rows inserted or deleted like once every year, or maybe a quarter or something like that, that's relatively infrequent. So an index on there would be fine. But let's say I have a sales table and the data going in is constantly changing. Let's say 200, 300, 400 changes every hour in a day. This would be a very horrible table to put an index on. Almost immediately within the day, you'll have fragmentation levels that would greatly increase. So this would be a horrible way to use indexes. And on top of that, because of the DML actions, whenever you do have a table with an index on it, it also causes the DML actions in general just to run slower because they do have to go through, sort through the B tree, find that information, and perform deletes and things like that. So overall, we have our kind of ups and downs of using indexes, and these are the main down points.